Welcome to the world of advanced Git commands, where we'll be mastering Git workflows and operations. Git is a powerful version control system, and this video will take you beyond the basics. We will explore a variety of topics from advanced branching strategies to understanding Git's internal workings. Let's start with advanced branching strategies. We'll explore the feature branch workflow, a common strategy that involves creating isolated branches for each new feature. This helps maintain a clean main branch and allows for parallel development. Next, the Gitflow workflow, which is a structured branching model. It utilizes dedicated branches for different purposes, such as features, releases, and hot fixes. Finally, the trunk-based development, which uses short-lived feature branches merged frequently to the main branch using feature toggles. Some useful commands are also listed here. To create and switch to a new feature branch, use the command git checkout-b, followed by the name of your branch. To list all the branches, both local and remote, use git branch-a. To create a branch from a specific commit, use git branch, then the name of the branch, and finally the commit hash. And to delete a branch after merging, use git branch-d and the name of the branch. Now let's explore advanced merging techniques. Git offers different merge strategies to handle various scenarios when combining branches. A fast-forward merge is used where a linear history is maintained. A recursive merge is the default strategy that uses a three-way merge and ours, or theirs will favor one side of the branch during conflicts. When merging, you can use the command git merge no fast-forward, followed by the name of the branch you are merging. This ensures a merge commit is always created, even if a fast-forward merge is possible. Git merge with the X flag and the ours parameter, followed by the branch name. This automatically resolves conflicts by favoring changes from the current branch. To abort a merge with conflicts, use git merge --abort. The key difference between merging and rebasing is that merging preserves the entire commit history along with any merge commits, while rebasing creates a linear history by rewriting commits. A visual diagram showing difference between merge and rebase is displayed. Here is about rewriting Git history. One powerful way to rewrite history is by using interactive rebase, which allows you to reorder, edit, squash, or drop commits. We can also use commit amending. With this, we can update the most recent commit with new changes or modify its message without creating a new commit. Remember the golden rule: never rewrite history that has been pushed to shared repositories, as this can cause issues for other collaborators. To amend the most recent commit, use the command git commit --amend-m and then the new commit message. To start an interactive rebase for the last three commits, use the command git rebase -i head followed by ~3. During an interactive rebase, you can squash multiple commits into one by changing the word pick to squash in the editor. Force push after rewriting history with the command git push --force with lease. Advanced Git stashing involves more than just saving your current work. You can create a named stash with a descriptive message using the command git stash save, followed by your message in quotes. List all your stashes with details using the command git stash list. You can apply a specific stash without removing it from the stash list with git stash apply and the stash identifier, such as stash@1. To apply and immediately remove a specific stash, use git stash pop, followed by the stash identifier. You can even create a new branch from a stash using git stash branch, then the new branch name and the stash identifier. Sometimes you only need to stash specific files. For this, use the command git stash push -m a message and then the path to the file or files. Stashing is perfect for temporarily saving changes when you need to switch branches but are not ready to commit, to pull changes without committing your work in progress, or for experimenting with changes you might want to discard. By default, git stash only saves tracked files with changes. To include untracked files, use the -u or ~include untracked flags. To include both untracked and ignored files, use the -a or ~all flags. Git Bisect is a powerful tool for finding bugs. It uses a binary search algorithm to help you identify which commit introduced a bug by testing each commit in a range. Git Bisect divides your commit history in half repeatedly, allowing you to pinpoint the problematic commit in logarithmic time. For faster bug hunting, you can run Bisect with a script to automatically test each commit. To start the Bisect process, type git bisect start. Mark the current version as bad with git bisect bad. Mark a known good commit using its hash with git bisect good, followed by the commit hash. After testing the current checkout, use git bisect good if the bug is not present, or git bisect bad if the bug is present. To end the bisect session and return to your original state, use git bisect reset. Git hooks are scripts that Git executes before or after events like commit, push, and receive. They are useful for automating workflows and enforcing policies. A client-side hook example is the pre-commit hook. This runs before the commit creation and can be used to run linting or tests. The prepare commit message hook modifies the commit message template. The commit message hook validates the commit message format, and the pre-push hook runs before pushing to a remote repository. Server-side hooks include the pre-receive hook, which enforces project policies, the update hook, similar to pre-receive but on a per-branch basis, and the post-receive hook, which triggers continuous integration and continuous delivery or CI/CD, and notifications. Here is an example pre-commit hook script in Bash. This will run ESLint on staged files. If ESLint fails, the commit will be aborted. Git submodules allow you to link external repositories within your project while keeping their commit histories separate. This is useful for including libraries or shared components. Git Subtrees, on the other hand, merge external repositories into your project with a shared history, which is better for incorporating code you plan to modify. Use submodules for third-party dependencies you won't modify, and subtrees when you need to modify the included code. To add a submodule to your repository, use the command git submodule add, followed by the repository URL, and then the path to the submodule. To clone a repository with submodules, use the command git clone --recursive, and then the repository URL. To update all submodules to the latest version, use git submodule update --remote. To add a subtree to your repository, use git subtree add --prefix equals the path to the subtree, then the repository URL, the branch, and finally the squash flag. Understanding Git internals can greatly enhance your Git skills. Explore Git objects using the command git cat file -p, and then the object's hash, such as head. View the commit graph with git log --graph --one line. List all objects in the repository with git fsck --full. Show the contents of the index, which is the staging area, with git ls files --stage. Examine a tree object, which represents a directory, with git ls tree, and then the object hash, such as head. Git uses for main object types: blobs, which store file contents; trees, which are directory listings pointing to blobs or other trees; commits, which point to a tree with metadata like author and message; and tags, which are named references to specific commits. Git is a content-addressable file system. All objects are stored by the secure hash algorithm 1 or SHA-1 hash of their content, creating an immutable database that enables Git's powerful features. To continue your Git mastery journey, check out these resources. Some great books and documentation include Pro Git by Scott Chacon and Ben Straub, Git Internals, which is the official documentation, and Git Magic by Ben Lin. For online resources, explore Git Flight Rules, which offers solutions to common problems, Atlassian Git tutorials for advanced workflows, and the GitHub Learning Lab for interactive courses. Useful tools and extensions include Git Large File Storage or LFS, Gitflow for workflow automation, and Husky, which makes Git hooks easy to manage. Thank you for attending this advanced Git session. We hope you found it informative and helpful. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.